Thank you all for joining us this fine morning. Today we are talking about what to expect from Wi-Fi 6E. We've got Jim Vajda here, who's going to be speaking on this topic. So I will let you take it away.
Sounds good. And I will bring this up. Man, Anders is on fire. He says not everyone in the world is allowed to use 6 gigahertz yet. And that is definitely true, although that situation is improving. So if you don't know me, my name is Jim Vajda. I am the Chief Wireless Officer here at 7 Signal and CWNE. And today I just want to give an update on Wi-Fi 6E. And if we could just, Heather, could you confirm that you're seeing my slides?
Yep.
Okay, good. Zoom just looks a little different today for me. So what is Wi-Fi 6E? So Wi-Fi, just a quick refresh on Wi-Fi 6E. Wi-Fi 6E takes the 802.11ax protocol that is branded as Wi-Fi 6, takes the exact same protocol and extends it into the 6 gigahertz band. So Wi-Fi 6 is 802.11ax in 2.4 and 5 gigahertz. Wi-Fi 6E is 802.11ax in 6 gigahertz. And it's a big deal because that 6 gigahertz band is huge. There's 1200 megahertz of spectrum available there, which you can see in this graph on the right. And many countries, starting with the US, have made the full 1200 megahertz available for Wi-Fi and other unlicensed users. And some countries have started with 500 megahertz or so and are considering adding more. So it's a big deal to have that much more spectrum available because you can see the other bands, 2.4 and 5 gigahertz, certainly significantly smaller than that. And just a refresher on 802.11ax, Wi-Fi 6, and a couple of the things that really stand out in terms of real world benefits that are actually being realized in enterprise networks from 802.11ax. In my mind, maybe the biggest one is the increase in spatial streams on the access points. Of course, clients are almost all 2 spatial streams now with 802.11ax, but many APs in the enterprise are 4 spatial streams, and some go all the way up to 8 spatial streams. That gives us better rate at range. That helps improve transmit beamforming. It improves receive performance of the AP, and it gives users a overall connection stability, we'll say, improvement. 1024 QAM, that's the feature that enables the crazy fast data rates that 802.11ax advertises. And just like with 802.11ac, where we were all kind of surprised at how well 256 QAM worked, I think we're seeing the same thing with 802.11ax, with that there was skepticism that 1024 QAM wouldn't work if you were 3 feet away from an access point or further away than that. But actually, it's surprising, the distance at which those 1024 QAM data rates can be sustained. And then OFDMA. So that's the big multi-user technology that's part of 802.11ax. It's still a little bit to be determined. I think that part of the reason that it hasn't been the huge feature that we thought it was is because in the legacy bands, 2.4 and 5 gigahertz, there's still all the old 5s, 802.11n and AC operating there. And I think we also had inflated expectations for OFDMA, thanks to the way it was perhaps mismarketed by some folks. which gave us the expectation we would see multi-user operation almost constantly. But the truth is, often, in fact, most of the time, we don't need multi-user operation, and OFDMA is really, beneficial in just a subset of cases. So having a look at the 6 gigahertz spectrum that Wi-Fi 6E takes advantage of. Here in the US, you can see how that's broken up into and how it's channelized. There's 59 new 20 megahertz channels, which is just incredible. And they're all available with the low power indoors access points that are available today. And the APs don't have to do any incumbent detection if they're low power indoors APs. So we don't have any of the DFS challenges that we have in the 5 gigahertz band. We can, as long as our APs meet that low power indoors LPI requirement, then they can use the whole spectrum here in the US without any other requirements, and that's really wonderful. So that gives us 14 80 megahertz wide channels. So this is the band where we finally are able to use those wider channel widths in the enterprise, where we normally don't go above 40 megahertz. 80 megahertz is going to be a reality for a lot of enterprises. But if you do want to use 40 megahertz or 20 megahertz, you have so many channels to reuse. You can get incredible density and still have pretty good channel reuse, which is wonderful. So one of the things that is unique to the 6 gigahertz band is we've got these 2 classes of access points. I just mentioned LPI, which you see across the top, and they use all the available channels here in the US. But the other class is standard power. So these are APs that can transmit at higher power and have to check in with what's called the automated frequency control system in AFC to make sure they're using they're using channels that are not going to interfere with incumbents. One of the big users of the band are outdoor private point-to-point links, microwave links, like you can see on that tower in the image there. So if we're using higher power and also standard power APs are the only class of 6 gigahertz APs that are allowed to use external antennas, then we need to play by these rules. And the other limitation with standard power is that we can't use the Uni 6 or Uni 8 bands. There's so many incumbents there. The FCC just said, no, we're going to keep standard power APs out of these zones and only allow them to operate in Uni 5 and Uni 7 under the control of an AFC. So the AFC still has some real serious advantages over what we did in 5 gigahertz with DFS detection. Essentially, the radio or the wireless controller is going to check in every day with the AFC and say, here are my APs in terms of their physical location, and what channels am I allowed to use? And the AFC will do some advanced RF modeling and tell them, okay, here's the channels you can use. And then off we go, and we'll start using those channels. So we don't have the issue of false positives with DFS, or just, middle of a busy day and suddenly the AP changes channel because of a sudden radar detect that you haven't seen in 6 months, but now it's everywhere. Those issues are gone, and that's really awesome. So just to, kind of set the stage though, everything today that you can buy is all LPI. Standard power, that's still being worked out at the FCC. The AFC systems are still being stood up, and it's kind of a work in progress. So if you're buying enterprise access points, Wi-Fi 6 EAPs, they are all LPI. However, I think some of the hardware that's been released, some of the APs that have been released have been released with the intention to have them recertified for standard power operation when that's available. So you might be able to use a bit higher power one day on those APs you're buying today. But that's an interesting question to ask an AP vendor if you're in the market for new Wi-Fi 6E APs. I also mentioned with the AFC system, if you're familiar with CBRS, it's a similar concept to the Spectrum access system, the SAS system that uses. And there's an earlier precursor even in Wi-Fi with 802.11af Wi-Fi in the TV white space. A similar framework to the AFC was developed. I don't know if anything ever got actually rolled out for that, but similar idea was there. So there are some challenges with standard power. One of them, probably the biggest one, is that for a client to connect to a standard power AP, it must be FCC approved to do that. So one of the differences here is now there are different client certifications from the FCC, not just access point certifications. And you can see from this image that we have indoor clients that can connect to LPI APs. We have dual clients that can connect to LPI and SPAPs, and we have standard clients that can only connect to standard power APs. A couple other classes as well, but we'll just focus on those. So we need our clients to be dual clients to use both. And most are only in this indoor client class, and at least today, would not be able to connect to those standard power APs. And they can see that actually it's in the beacon of a 6 gigahertz radio. There's a regulatory bit. And if it's flipped to a 1, that indicates that the AP is a standard power AP. And an indoor client will know I can't connect to that. And that's how it's set up here in the US. But, so if that's the way things stay, then, standard power APs, it'll be, a long time before they're deployed, because why would you deploy those without most clients supporting them? And we know that Wi-Fi clients, especially on the consumer end, are not fast to, get recertified by the FCC and things like that. So, that's a problem. But I'm also, I think there's some awareness of this, and possibility that some of these rules may change in the future. So just something to keep an eye out for, because it is really going to hamper standard power APs. And you can think about stadiums and outdoor areas where they'd really like to not take advantage of high power, but definitely want to use external antennas and install access points outdoors, and are hungry for spectrum, right? That's a great use case for Wi-Fi 6E, that they're probably concerned about this. So let's look at the hardware that's available today. Pretty much all the major enterprise Wi-Fi vendors have access points available now, or I should say released. Maybe they'll take a purchase order. In terms of actual availability, that's of course affected by the chipset shortage. All those APs are low power indoor APs, some of which again might get recertified for standard power operation in the future. The big thing in the enterprise on the client side is the Intel AX210 adapter that's been out for 2 years now. And if you've been able to, influence client procurement for your Windows fleet, maybe you've already got a significant number of these deployed. And now it's just a matter of getting APs deployed so they can take advantage of 6 gigahertz. Then there's some smartphones out there as well. Some of the more higher end smartphones, the Samsung Galaxy S21 and S22 Ultra, and now Google's Pixel 6 and 6 Pro. They all support Wi-Fi 6E. So those aren't typical enterprise clients, but they certainly will show up in guest networks as if you operate a public network for visitors in your enterprise. And more. Many more, actually. And if you look at the Wi-Fi Alliance's website to see the 6E certified clients, you'll see quite a few more there as well. So a couple of the requirements and considerations for deploying Wi-Fi 6E in the enterprise. First, the access points themselves are significantly more expensive. And that's just a reality of a tri-radio access point that might have across all 3 radios, 12 or even 16 radio chains. That's an enormous amount of radio technology in a single enclosure. And of course, supporting all that and the high performance of all 3 radios requires a significant amount of compute power as well. And don't forget that with Wi-Fi 6, with 802.11ax, that capability is added to the 2.4 gigahertz radio as well. So that radio gets a big upgrade in performance as well with Wi-Fi 6 and 6E access points. We've got 802.11ax across all 3 radios now. So that's a consideration. The budget, of course, but you really got to look carefully at your switching infrastructure too. This is the big obstacle or challenge before deploying Wi-Fi 6E in the enterprise, because these new high performance 3 radio APs need, almost all of them need 60 watts of PoE. Cisco calls it UPoE. The standard now is 802.3 BT. But with just a few exceptions, you have to have that to power these APs and get full performance out of them. So that's a big ask. If you need to see if you have 60 watt PoE in your switching infrastructure, and also figure out not just if it's there, but do you have the power budget in your switching to power all the APs at once that you want to connect to those switches? Big consideration. The Wi-Fi 6E APs often come with multi-gigabit Ethernet ports, known as N-base T. which, I'm of the opinion that gigabit Ethernet is more than enough for Wi-Fi 6E APs. But if you do want to take advantage of those multi-gigabit uplinks, then you've got to make sure you have that on the switching side too. And then there's this cascade of requirements, right? If we have a bigger power budget from our PoE requirements on a switch, and we have a requirement, say in a hospital, to have a UPS that powers that switch for an hour, or somewhere else that might have a requirement like that, then that switch has a higher power draw, and we might then be required to upgrade our UPSs in the IDF in order to meet our backup operation requirement. And higher power UPSs, higher power switches sometimes need larger amperage outlets from the wall. So you got to kind of think through all this and make sure that from a PoE and access layer switching perspective, everything's okay. And then if we're pushing this much power through our cabling too, we want to make sure that we're within requirements there, because then there could be a pretty significant heat buildup in bundles of cabling. And we did a great webinar, I think it's been 2 years now, with Devin Aiken on the future of PoE and cabling. That's a good reference to learn about that. So a lot to think through. And, one of the things to think about too, just to play devil's advocate here, is well, what's the if we have to replace all our switching and UPSs and so on, what's the business driver for this? Why do we need to do it? Is it just because it's time to replace our APs and this is the next generation? Well, if that's the case, we there's still dual band APs that might work. So there's a few things to think about it. And usually when we're talking about new generations of Wi-Fi, speed is the thing that gets marketed the most. But I don't think that's actually the best way, or in reality, I don't think that's where the benefits from Wi-Fi 6E really come from. So for example, this is a graph of the average over the air downlink traffic per access point in a hospital for a week. And this is a hospital with a fairly dense deployment, a lot of wireless clients, a lot of mobility. It's 802.11ac, and I can vouch for the design, we'll say. So here, the average AP in the downlink direction is pushing somewhere between 0.5 megabit to 2 megabits per second on average. Of course, there's spikes that come and go, but that's not a lot of traffic, really. And this is, again, a hospital with a lot of Wi-Fi clients, but they're, those clients aren't extremely throughput hungry. They're not pushing a high volume of traffic. They're sending quick updates, medical telemetry kind of things. And they're idle an awful lot of the time. Okay, but what about the actual RF links? Are they saturated or is it healthy? If we look at the same APs, just to look at the channel utilization, again, average. So there are, definitely spikes that aren't showing up here, but on average, in 5 gigahertz, we're between 2 and 4.5% channel utilization. The graph stops at 4.5%, not at 100%. So that's very low. That's a lot of unused capacity in the 5 gigahertz band. It kind of goes back to that poll question I had, that everyone has a capacity need that 6 gigahertz is going to solve. And I don't think that's true. I think if you've done a good job with your design in 5 gigahertz, in many places, even with high density designs, there's still ample capacity available. And just because you've got thousands of clients, and because because you might have some co-channel interference, doesn't necessarily mean that you actually have a real capacity problem that you can't just solve in 5 gigahertz today. Certainly it is a use case for some networks, but for many, I don't think the capacity is a big driver for 6 gigahertz. What I do think is a big driver for it is improving channel access and lowering latency for reliable real-time applications. What we have to deal with in Wi-Fi, because we operating the unlicensed spectrum, is that we're using channels that our neighbors are using, VoIP handsets are using, incumbents are using. There's interference, and there's non-Wi-Fi protocols and other things that we're sharing the channel with, and we just have to live with it. We don't have any special priority to use the spectrum we have, and so that's can have a big impact on latency. And this is even when we apply QoS, we're still kind of that has a influence, a probabilistic influence on channel access, but it doesn't really change the fact that there's other protocols, there's interference, and it's hard to get QoS to work reliably in both directions as well. So for Wi-Fi, again, to really deliver very low latency, it needs mostly empty spectrum, and that's what we get from 6 gigahertz. So that's one way to think about the benefits of 6 gigahertz. I kind of poo-pooed the congestion and capacity issue, but there definitely are real-world networks today that are desperate for more spectrum, because if you look at a channel scan, you see every single channel occupied by APs, and they're all extremely busy. So you can think about stadiums and arenas, very high density and large public venue, wireless LANs, where, these are going to really benefit from extra spectrum right away. Certainly dense residential areas as well, because in the 5 gigahertz band, in residential areas with consumer APs, we're not going to use DFS channels because those APs aren't certified to use them. So we've just got 8 channels, probably using 80 megahertz channels, and it's probably pretty ugly. So right away, we'd see a benefit there to relieve congestion. Anywhere else there's RF congestion is going to lead to high latency, at least. Smaller use case, but if you do have applications that require high throughput, which to me is 20 megabits per second or more, although that's a teeny tiny fraction of the kind of throughput numbers that marketing throws around. In the real world, very few applications require anything close to that. But maybe you have something like that, and that would be a great use case for Wi-Fi 6E. And then, just again, the things that really probably aren't great use cases for, despite the way it's marketed for Wi-Fi 6E, uncompressed video streaming. Not sure why you'd ever do that wirelessly. AR and VR. I mean, I'd love to know if enterprises really are doing augmented reality and virtual reality projects, and they need super high throughput for that all over the enterprise. I'm not familiar with a real project like that yet. IoT, yeah, the protocol helps IoT, but most IoT devices are 802.11n or G even. I think it'll be a while before we see many 802.11ax IoT devices. And now, the latest thing I've seen in marketing is that we need to upgrade to Wi-Fi 7 so that we can support the metaverse. And I'll leave that one there. So some of the things that you can do in the real world with Wi-Fi 6E today that are going to give you benefits. Well, we mentioned that this is a technology coming to smartphones first. Those are clients that turn over very quickly. So we could use the 6 gigahertz band for guest and BYOD offload from 2.4 and 5 gigahertz, where most of our enterprise devices are, and that's going to have a carryover effect where performance in those legacy bands is improved by moving clients up to 6 gigahertz. Certainly lower latency, right? This is where we're benefiting from mostly empty spectrum, and real-time apps are going to do better. We could set up a greenfield SSID, something that's maybe only 5 and 6 gigahertz enabled, and turn on all the great enhancements to 802.11, like 802.11r and K and V, W, and so on. WPA3, which is of course required in Wi-Fi 6E. Set this up as our modern high performance SSID, and keep all the low performing clients off of it. Maybe give it a cool name like 7-Signal Premier or something like that. And that can help reinforce also that clients are a big part of the overall Wi-Fi experience. So you can tell the business that, yeah, 7-Signal Premier, that's our SSID for the best clients that can do all the best things that we offer. But you bought a client that doesn't support all these things, so it has to go on 7-Signal Legacy or 7-Signal Slow or whatever you want to call it. And then that sets expectations about the performance that those clients can actually achieve, and also helps the business, the organization, understand that not all clients are the same. Of course, we're doing some. You can do that today with 2.4 and 5 gigahertz, but you can extend that idea into 6 gigahertz as well. So this is interesting and kind of an out there idea, but we have so much spectrum in 6 gigahertz. What if we divided it up and said, cut a chunk off and say, maybe those channels in Uni 8, there's 12 20 megahertz channels there, which is by itself a big chunk of spectrum. What if I just slice that off and said, okay, my super most important mission critical highest priority devices are the only devices that get to use those channels, and we're not sharing them, that spectrum with guests or anything else, just those VoIP handsets or those POS tablets or whatever it happens to be. There's certainly enough spectrum here to support that, which is an interesting idea. Of course, the drawback here is now, in order to achieve that, we have to create 2 layers of 6 gigahertz coverage, one for the rest of the band, and then another layer of coverage just for this high priority subband. And that's going to be pretty expensive. But it's something to consider, right? Maybe there's a justification for that. So one thing to highlight, of course, with any new Wi-Fi technology, history has shown that there will be bugs. The AP vendors want to get their products out and released as soon as possible. And that often means that stable enterprise-ready code comes after these things are released. And that's just a factor of life with enterprise Wi-Fi that we all have to live with and we all have to be aware of. Also, with a new generation of hardware like this, and certainly remember seeing this with 802.11ac and 802.11n, the first products to market tend to be there because they were the fastest things that could have reached the market. But the second generation of products tends to be better designed, have better engineered, and be higher quality overall. So just keep that in mind. The second generation stuff sometimes lasts a little bit longer and performs a little bit better. A couple of the technical differences with Wi-Fi 6 and 2.4 and 5 gigahertz. We've talked about a lot of these things. One of the things I do want to highlight is with Wi-Fi 6E, we can only use WPA3 and OWE. So OWE is opportunistic wireless encryption, and that's used for public networks, open networks. So that's an inflection point. As soon as we're starting to support Wi-Fi 6E, we have to enable WPA3 for the SSIDs that are going to operate there. And if those SSIDs also operate in 2.4 and 5 gigahertz, then you need WPA3 support there as well. So that's a big consideration. Channel widths will typically be larger in Wi-Fi 6E. Our RTS-CTS protection is no longer needed because we can establish a TX op from the HE preamble. And then didn't talk about this much, but the AP discovery in 6 gigahertz is totally new to Wi-Fi. This would be something to keep an eye on in terms of client issues and bugs. But the primary way that 6 gigahertz APs are discovered will be through out-of-band discovery, probing and scanning in the 2.4 and 5 gigahertz bands. So a Wi-Fi 6E client will probe and say 5 gigahertz. If it gets a response from a 5 gigahertz AP, that probe response will have an information element that tells the client also about the 6 gigahertz radio that access point is operating. So that's how that's going to work. And there's some real potential here for spectral efficiency gains over Wi-Fi 6, even though the protocol is the same. The differences in spectrum make a big difference. So in 2.4 and 5 gigahertz with Wi-Fi 6, the AP has to win channel access in order to use OFDMA or some of these other multi-user technologies. And it's competing equally with the legacy clients there, the 802.11n and AC clients. In 6 gigahertz, we don't actually have that problem anymore. because all the clients there are 802.11ax. The AP can use this multi-user EDCA feature, which I discussed in my WLPC talk, to bias channel access so that the AP wins channel access more often. So scheduling can be, and OFDMA can be more of a reality there. Mention the differences, that we don't need RTS, CTS, and 6 gigahertz. Although I do see some APs still doing that, at least on the consumer side of things. And then spatial reuse, interesting feature in 802.11ax, but with Wi-Fi 6 and 2.4 and 5 gigahertz, it's only the AX clients and APs, of course, that are going to take advantage of that. And in 6 gigahertz, it's all the stations because they're all 802.11ax stations. So just a quick illustration of what all the efficiency gains, how that all adds up. If you look at 802.11ax and 5 gigahertz, if we want to transmit to 3 different stations, we're probably just going to do single user, normal, what we expect from Wi-Fi operation, and establish a TX op, transmit to each one, win channel access again, and so on to get to all 3. But in 6 gigahertz, the best case scenario is that the AP only has to win contention once and can go straight into downlink OFDMA, transmit to all 3 of those clients at once, and then get the block hacks from those clients in response, which would actually happen in a period of uplink OFDMA in response. So that's, this isn't perfectly aligned to scale in terms of time, but it's just one of the ways that we really could get more efficient use of the spectrum in 6 gigahertz with a completely 802.11ax environment. And this is really the biggest improvement will come from small frames, large frames that go along with huge downloads and throughput tests. Still, even in 6 gigahertz, probably better served with single user operation and aggregate and frame aggregation. And so if we're looking forward, the big thing that I'm keeping an eye on is the iPhone 14, which will certainly, if that's and I don't have any insider info, but if that's a phone that supports Wi-Fi 6E, and as we know, those are devices that turn over very quickly, and of course are extremely popular, especially here in the United States. That's going to be a sudden large increase in Wi-Fi 6E clients. So keeping an eye out for that. Keeping an eye out for what's going to happen with standard power access point and dual client rules here in the US. The chipset availability challenges remain. That's true for clients. It's true for access points, certainly. One thing that plays in the favor of 6 gigahertz, at least in some cases, is that AP vendors, if they just have recently released a Wi-Fi 6E AP, they don't have a huge backlog of orders for it yet, like they might for their Wi-Fi 6 APs. So you might be able to get, get in line before getting a shorter line than you would for those dual band Wi-Fi 6 access points. And then, I'm already aware of some Wi-Fi 6E deployments occurring, specifically in higher education, where congestion in areas like lecture halls And I imagine dorms as well makes a great case for Wi-Fi 6E. And of course, with all the, the fast client turnover from students bringing in the latest and greatest every semester, they're going to have 6 gigahertz clients there already today. So that's already happening. Okay. And with that, Heather, if we have a little time, we can do a little bit of Q&A.
Awesome. And we've had a very, very active chat. Lots of conspiracy theories and all that good stuff. So
excellent.
Thanks for being active, guys. Love it. Love it. We do have several questions in the Q&A. I don't know if you want to help me pick them out. Let me see.
Yeah. So yeah, we'll start with Manish. And Manish asks, where is the centralized database located for the AFC to check the allowed channels of operation in its area of operation? So very good question, Manish. Here in the US, and you keep hearing me say in the US, because this is very, very much domain specific, regulatory domain specific. But this is starting in the US, and what they use is the FCC's ULS database. I want to say that stands for Universal License Search Database. And that tells the AFC where all the existing 6 gigahertz transmitters are, what frequency they're using, what transmit power they're using, and that gives the AFC the data it needs to model the RF environment and predict where interference from Wi-Fi 6E access points will take place. So that's where that comes from.
Awesome. Probably have time for like just one or two more.
Yeah, couple questions about why we don't need RTS CTS in 6E. And the answer is that the purpose of RTS CTS is to distribute the nav at layer 2 using frames that are transmitted at very low data rates, so the nav gets distributed widely. And it also, helps with the hidden node problem. In 6 gigahertz, we have the advantage of all stations being 802.11ax stations. And one of the new things in the high efficiency preamble that they use is a TX op field. So the preamble itself in data frames distributes the nav. And of course, the preamble is, no matter what the rest of the frame is transmitted with, the preamble is sent at a very low data rate. So it distributes the nav widely and sets the timers for all the stations on the channel and fulfills the need or the purpose that RTS CTS did before.
Awesome. Well, I hate to cut the Q&A short, but we've got to get rolling into our 7 minutes with 7 signal with Eric. If you do have questions that weren't answered in the session or during the Q&A, just follow up to the email that'll go out tomorrow, and we'll make sure that we get any of your questions asked or answered. Hi, Eric. How are you doing today? Oh, he's on mute.
Let's try that again, shall we?
Perfect. There we go. Loud and clear. Yep.
Awesome. Great topic today. Wow. So glad to be here. Love talking about this new stuff, Jim. This is fantastic. Well, what I'm going to share with you guys today is just how 7 Signal is going to be set up to allow you to see all of this cool stuff that we've been talking about for the past hour. So let's take a look, shall we? Do the old screen share. What we're doing here is and just give me the thumbs up if you can see that. All right. So what you can see here is we're looking at a device page inside 7 Signal Mobile Eye, good old James on the Huggy Bear network. And so what's neat about this is, okay, where are these things going to show up in our system once we start having clients that are on these new Wi-Fi 6E access points? So for example, right here in the middle, you're going to be able to see how a client device actually moves from one band to the other. We want to know, are people actually getting on the 6 gigahertz radio or not? What's really interesting, and here you can see that, you know, the device is kind of flip-flopping between 2.4 and 5. Are we going to see similar behavior when we get to Wi-Fi 6E, where those 6 gigahertz signal strengths are probably always going to be a little bit worse than 5 gigahertz signal strengths? Is my client even going to roam over to the 6 gigahertz radio when given the choice between 5 and 6? Who knows? 7 Signal knows, because we're going to be able to see it right here and now. And then the other thing that Jim talked about was, okay, am I going to be able to, once I am on 6 gigahertz, am I going to be able to see differences in data rates? So we're going to be able to see that over here as well, in the data rates and how those change. Am I able to achieve the, you know, the 1024 QAM and get those super awesome data rates on those 80 megahertz wide channels that have been promised to me by my vendor? And is that going to then result in the lower latencies, the better throughput? And once again, we're measuring that also. So when I'm on 6 gigahertz, I'll be able to actually see here in 7 Signal, okay, am I experiencing better throughputs, better latencies to the applications out there that I've set up in my configuration that are important to my organization? Okay, guys, well, that's what I wanted to show you guys today. I mean, really cool stuff. This is exciting. It's coming down the pike. Obviously, you know, we're going to have to do a little bit of wait and see, but 7 Signal is going to be poised to pounce. We're going to be ready to roll. And Jim, I got to tell you, I'm really excited. When we're done here today, I want you to Slack me the password for the 7 Signal Slow SSID. If you could do that for me, I'd be greatly appreciated. So that's what we have for you today. Thank you very much for joining us. And remember, you and me, we can't see or hear Wi-Fi, but 7 Signal can. Thanks for joining us.